Hello learners, we all know that statistics is the backbone of data science. So you can expect a very important question in an interview. What is the significance of covariance and correlation? So first of all, let us try to understand what is covariance. We know what is variance, which is nothing but spread of the data. We have discussed in the previous tutorial. So if you have missed that video, please go and watch the video on variance and standard deviation. I'll be giving the link in the description box. And then what is covariance? Co means co-education, cooperation. So like that, covariance means it is basically the relationship between the two variables. Is it exactly the relationship between two variables? So let us now try to understand with the help of an example. So let me ask you a question. Just think for a while and give me an answer. So just assume that the temperature is increasing. And what happens to the ice cream sales when there is a rise in temperature? Exactly. Whenever the temperature increases, the ice cream sales also increases. Whenever the temperature decreases, the ice cream sales decreases. So I can say in summer, the ice cream sales would be higher, right? In rainy season or in winter, it actually decreases. Let me take another example now. Whenever the temperature decreases, what happens to the flu cases or the fever cases? Exactly. Whenever the temperature decreases, definitely the flu cases would be increasing. So let us now analyze these two cases. So when the temperature is increasing, ice cream sale is also increasing, which means that both are changing in the same direction. Whenever the temperature decreases, the ice cream sales also decreases, which means that both are changing in the downward direction. So can I conclude that in the first example, both are changing in the same direction? If you take this one, temperature and flu cases, you can see like whenever the temperature decreases, the flu cases is increasing, which means that both are changing in the opposite direction. So as I told you, covariance signifies the direction of relationship between two variables. So how can I get that? Right? So how can I measure that? So let us now try to do that. So covariance of x and y, where x is nothing but independent variable and y is nothing but dependent variable. Summation of xi minus mu base x, y minus mu base y divided by n for population. So let me tell you what is this xi. Xi is nothing but individual value of x. Mu is nothing but population mean of x. And this is again individual value of y. And this is nothing but exactly population mean of y divided by number of observations in population. Likewise, if I find for sample, covariance of x comma y is equal to summation of x minus x bar into y minus y bar divided by n minus 1. What is the x bar and y bar? Which is nothing but sample mean of x and this is sample mean of y. So now this is nothing but number of observations in sample. So let us now try to solve a problem so that you can understand it better. So x values are 1, 2, 3, 4, 5 and y values are 2, 4, 6, 8, 10. So what is the formula? We have seen like x minus x bar, y minus y bar. So let me go ahead with this one. So x minus x bar, when I find, if you find out the mean of 1, 2, 3, 4, 5, we will be getting mean as 3. So 1 minus 3 is minus 2, 2 minus 3 is minus 1, 3 minus 3 is 0, 4 minus 3 is 1, 5 minus 3 is 2. Likewise, find y minus y bar. So y bar is 6, 6 minus 2 is, yeah. So y minus y bar, right? 2 minus 6 is minus 4, 4 minus 6 is minus 2, 6 minus 6 is 0. Yeah, exactly, right? So this is how it has been proceeded. Now x minus x bar into y minus y bar. Multiply this, we will get 8. This, 2, and so on. When you add everything, we get it like 20. In case if I get covariance of it, 20 divided by n minus 1, right? So 20 divided by, there are 5 observations. So 5 minus 1, which is equal to 4. So what is the answer now? If I find sample covariance, answer is 5. If I find population variance, 20 divided by 5, the answer is 4. So what do we understand from this, right? So now here you can see x is increasing, y is also increasing, and you can see that the covariance, we get it as positive. So now just try to solve this one. I'll give you a minute time. Please solve this problem now. Right, so x minus x bar, right? So if you find out the mean of it, you'll be getting it like 3, right? So let me change the, okay. So x minus x bar, 1 minus 3 is minus 2, 2 minus 3 is minus 1, 3 minus 3 is 0, 1, and 2. Likewise, if you take this, what would be the mean? Definitely mean would be 6. So 10 minus 6 is 4. This would be 2. This would be 0. This would be minus 2. This would be minus 4. So x minus x bar into y minus y bar. So we will get minus 8, minus 2, 0, minus 2, and minus 8. So add everything. What do we get now? Yeah, minus 10, minus 20. Divided by 4. If you find for sample, so you would be getting the answer as minus 5, right? So what does this signify when you get minus? You can see that x is increasing. What about y? Y is decreasing. So both are changing in the opposite direction, right? Both are changing in the opposite direction. You can see that answer is negative. So what can we conclude from covariance? If both change in the same direction, x and y, same direction, then the covariance would be positive. If x and y are changing in the opposite direction, and then we can say that covariance is negative. And what is the use of this number 5? What is the use of this magnitude? Nothing. That is the reason we move towards correlation. Right? So how do we find out correlation? Covariance of x comma y divided by standard deviation of x into standard deviation of y. So let us now calculate for this correlation equal to covariance, right? So we got covariance as 5 in case if you take it as population, and say if you take population standard deviation for 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. Let me take that. Right? So this was the problem. 1, 2, 3, 4, 5 and y is 2, 4, 6, 8, 10. So we already know how to find out standard deviation, right? When you substitute over here, you will be getting answer correlation as 1. So what does this conclude, right? So I can say that the correlation values would be ranging from 0 to 1. So whether there would be positive or negative, yes, exactly. Again, like a covariance, I can say here correlation as correlation. What does that mean? The strength of the relationship between the attributes. So the correlation would be ranging from 0 to 1. If the correlation is closer to 0, I can say that the correlation is less. If it is closer to 1, I can say strong correlation. If it is closer to 0.5, I can say that moderate correlation. So what is the significance of correlation, right? So that's the most important thing that we have to understand. Say I have several features in my data set. I want to know which features are really important, right? So in such case, correlation would be helping us to solve the problem. So how can we understand it better? Say I'm working on a model to predict the price of a house, right? Price of a house, right? So basically this is my dependent variable. I have independent variables like area of house, right? And also maybe age of house, also age of buyer, right? Say price of a house and area of a house, definitely how the correlation would be. If I talk about how covariance would be, covariance definitely I can say that it would be positive. Is there any use of the magnitude? No, not really. That's why we move towards correlation. Correlation we get like positive, and definitely we would be getting the value closer to 1. Because whenever the area of house is increasing, price of house also would be increasing. Same direction, so positive. There is a good relationship between area of house and price of house. So the value is closer to 1. So now you take age of house and price of house. I can say for sure, definitely this would be negative. Ignore about the price of the land. Just I'm talking about the price of house only, right? So I can say covariance would be negative because whenever age of the house is increasing, price of house would be decreasing. In case if I find correlation, how the correlation would be? Correlation would be definitely negative and the value may be closer to 1, right? Maybe like minus 0.8, minus 0.95 and so on. So if I take this price of a house and age of a buyer, I can say that covariance, how the covariance is going to be. Is there any relationship between age of buyer and price of house? No, right? So we can't say anything about covariance, no idea. If you think about correlation, definitely no correlation, so the output or the answer would be closer to 0. Now, if I am working on the model, I'll be knowing like, yeah, I can select this feature because correlation is higher. I can select this feature because correlation is higher. Here, there is no relationship. I'm talking about linear regression, right? If I'm working on the model of linear regression, I can take a decision whether this feature is important or not. So, let me repeat the point. Covariance helps us to find out the direction of relationship between the variables, and correlation helps us to find out the direction as well as the magnitude of relationship between the variables. right? Yeah. So if you have any questions here, please write it in the chat. So I would be giving the answers in the chat. Thank you so much.